According to the National Safety Council and medical research, 20% of backaches are attributed to inflammation such as arthritis. 10% are due to actual back injuries and other miscellaneous causes. 70% result from degeneration of spinal discs. That's right, aging of the spinal disc material causes the most trouble and can cause extreme pain even from routine body motions. You've all heard the routine warnings about bending your knees and lifting with your legs. We see people lifting boxes to demonstrate the proper technique. Those techniques are still correct, but we don't always pick up a box, or the item we want to lift is sitting under a storage rack or other difficult position. Today we want to explain how the back works so you'll have enough information to make the right choices on how to lift anything safely. We'll also discuss how strains and muscles work so you can prevent these types of back injuries also. There's no magic formula. All you need is a good attitude about safety and are willing to think about safety every time you lift anything. If you'll do that, it's difficult to have an injury. First, let's talk about the mechanics of the back. Each disc is a circular pad filled with gelatinous substance under pressure. The disc looks like a soft hockey puck with jelly on the inside. The disc works like shock absorbers or springs that provide a linkage to the vertebrae or bones, but prevents any sliding of one vertebra against another. The spinal cord is a bundle of nerves in a protected vertical passage behind the disc area. Nerve roots branch out through spaces between each vertebra and go to different parts of the body. The normal range of spinal movement is shown here, while bending forward and backward. You can see the nerve roots are in a vulnerable position because the spinal cord must bend and flex without the vertebrae slipping out of alignment. It is quite easy to wear out a disc with normal movement. As you bend and move, your discs are working, just like the shock absorbers in your automobile. Discs can become damaged through excessive twisting, turning, bending, and when this happens, the disc may spring a slow leak. Now, as the fluid leaks out, you can lose disc pressure. This loss of pressure in one disc can affect the entire linkage. It can happen at almost any age. You don't have to be old to wear out your disc. Back pain sufferers should pay constant attention to posture, standing, sitting, working, even while sleeping. The lumbar flexion or dynamic posture as shown here helps widen the opening that nerve roots pass through and reduce the chance of pinches. Regular exercise is encouraged, which promotes flexibility of the muscles and all the other body parts to keep you healthy. Okay, let's talk about those muscle strains. Actually, when you stretch, ligaments in your back stretch also. Now, if you stretch too far, these ligaments may tear or overstretch. They can be quite painful. Many times we must lift something over our head, so you're going to stretch your arms to reach the object. The best way would be to set the lifted object on a table or other support. Then reposition the object so your arms are doing the lifting, not your back. As a minimum, reposition your grip on the object to keep the weight centered. Arching the back during a lift makes nerve roots susceptible to pinching. Just remember how the discs protect the back and try to make the lift with your back as straight or in a normal position as possible. When you do this, the discs can do their job without damage and the ligaments aren't stretched so far that they'll tear. Naturally, medical research has provided us with some basics about your back to help you understand how the back works. The back works like any other machine on the lever principle. You have a load and a counter load. The load you're lifting and your back balanced on a pivot point or center of gravity. The heavier the load, the more counterweight you need, or some position to help offset that load. The back has a 10-to-1 ratio to the object you're lifting. If an object you're lifting weighs 10 pounds, it's going to take 100 pounds of pressure in your back to lift the object. This puts a lot of pressure on those delicate discs. Add in more weight, more length of the lever, or an awkward position, then you're adding much more pressure on those discs and, of course, the ligaments. That's why you hear safety and medical personnel telling everyone to bend your legs and squat down near the object you're going to lift. This keeps the discs lined correctly between the bones. Get a good palm grip. Don't use your fingertips. The palm grip is designed to make sure the object you're lifting doesn't slip out of your hands. Lift the object slowly to prevent any jerking movements that can cause discs to move out of their proper alignment, and bring the object close to your body. This reduces the lifting pressure based upon the 10-to-1 ratio of the lever. The closer the load, the less pressure it takes to lift. You have a good grip. The object is close to your body. Now stand up. You're using your leg power to do the lifting, not your back. That's the standard method of lifting safely, and it does work. Now, how about the more difficult lifting situations, such as trying to lift different types of objects in a less than ideal situation? Let's take a look. Did you notice how he used his free hand to provide support for some of the lifting? Anything you can use to provide additional support is great for your back. How about trying to install a car battery into an automobile? You have to be standing to get the battery over the fender and into the battery case. Can't bend your legs on this one. The next best thing to do is move your legs against the car's fender. This provides good support and assistance to your back when the battery is lowered into the case. Use your legs whenever you can to help reduce the load or pressure on your back. Keep in mind how your discs support your back, the 10-to-1 lever ratio, and that you have ligaments in your back that can stretch and possibly tear. Whenever you have a particularly difficult load to lift, you can use your good judgment and make the right decision how to lift properly. Naturally, if the load is too awkward or heavy for one person, get some help. Safe lifting doesn't have to be perfect, but it does have to be done safely. Twisting your back while lifting is extremely dangerous. Find another way to lift, because it only takes one wrong way to cause a problem. Perhaps you have been lifting improperly, twisting and lifting and stretching, and your back is still in good condition. Well, that doesn't mean you haven't injured your discs. Perhaps it just means that time, age, and body mechanics just haven't caught up with you yet. Maybe it means you're healthy and just one of those persons that will never get sick or experience an injury. Well, you're fortunate. But we urge each individual to practice safe lifting all the time, at home, play, and at work. Back injuries can be prevented, but you're the only person who has control over your well-being. The most important part of safe lifting, actually any type of job and home safety, is having the right attitude about safety and thinking about safety before you perform each task. Take time for safety because it's important to you, your family, and your job. Thank you.
In every working environment, from office to manufacturing to construction, one of the most important responsibilities employees have is to maintain a clean, neat, and orderly workplace. Every working environment is also plagued with the fact that you're busy. You've got a big job to perform, and there isn't always time enough to do everything that needs to be done. No matter your job, your craft, or what needs to be accomplished during the day, there is always time enough to keep your work area clean, neat, and orderly. No excuses, no reasons for not doing it. It's simply something that must be done by everyone in the work area. If you drop something, pick it up. If you see something that needs to be corrected, correct it. If you can't correct the hazard, report it to your supervisor so it can be corrected. Safety is an important responsibility, and it's a condition of employment. Maintaining your workplace in a neat, clean, and orderly fashion is a big part of your job, and it certainly is a big part of the safety program. A simple thing such as good housekeeping pays big dividends in the long run. If you stop to think about all the injuries and lost time that has resulted from poor housekeeping, you'd wonder why everyone doesn't participate. We could speculate all day long as to why some people don't pick up after themselves or leave their work area looking like a disaster. But let's talk about some facts. What really causes these unplanned happenings we call accidents? Chiefly, the primary cause of these events are due to being forgetful, tired, lazy, careless, inexperienced, disobeying safety or work rules, or just plain negligent. Attitude is the single cause of most of these unplanned events and injuries. Naturally, unsafe conditions and equipment may play some role, but attitude is the major key to safety in the workplace. If you have a good attitude about safety, you'll automatically keep your work area clean. If you have a poor attitude about safety, you really won't care whether your work area is clean or not. It's that simple. In an effort to gain the assistance of all employees and make everyone more aware of their housekeeping responsibility, let's quickly review some basic tips. Nothing exotic or magical about these reminders. They're all common sense, but by simply paying attention and doing your part to keep the workplace neat, clean, and orderly, you'll go a long way in improving safety, no matter what job you perform. Quite often, loose flooring or other walking surface hazards can be very hazardous. Use caution when walking over loose bricks, tiles, floorboards, stair treads, or other areas. If you spot a hazard, correct it. If you can't correct the hazard, notify your supervisor so the hazard can be corrected before an unplanned happening takes place. When you are walking, always pay attention to where you're going and be aware of the footing. The vast majority of slips and falls are a result of not watching where you're walking. Spills. Don't wait for wet spots to dry themselves. Wipe them up right away. If the wet spot is greasy or oily, use an absorbent material to completely clean up the spill. Even after cleaning an oil or grease spot, the floor surface may still be slippery. Using absorbent material or even common household cleaner to completely remove the oil or grease is recommended. Sawdust and wood shavings are quite slippery and should be cleaned up as you go. Leaving slippery sawdust on walking surfaces is hazardous, and this type of material is also a fire hazard. Take the time to clean up sawdust and wood shavings as often as possible. Stairways. Keep stairs clear. An extra trip upstairs might prevent a serious fall. Don't allow anything to be left on stairs, walkways, or aisles. All materials should be stored in their proper places. Tools and other materials must be kept in their proper places when they're not being used. Don't place sharp objects in your toolbox without some type of protection. You may be in a hurry and reach into a toolbox and pull out a cut finger or hand. Don't store rolling or easy-to-tip-over articles on shelves or carts. Watch out for small pieces of lumber, banding material, masonry, or other objects that could be tripping hazards. All extension cords should lie flat along the floor away from walkways. Quite often it's better to string electrical cords overhead to protect the cords and keep them out of the way. Remove, cut off, or hammer down protruding nails, staples, or steel strap. When these items are put into containers, use caution. Never reach into the container, as cuts, punctures, or other similar injuries are likely to occur. When working with wood, remove splinters from workbenches, tables, bins, shelving, or chairs. Use a broom and pan when cleaning up broken glass. Never pick up broken glass with your bare hands. It only takes a few seconds to make the area safe, and that's what safety's all about. Using common sense and having a safe attitude in every job you perform. Always work clear of suspended loads. If a load is moved about when you're working, stand aside until the hazard is passed by. When carrying long pieces of equipment such as pipes or ladders around corners or through doorways, watch the ends, or when possible, use two persons. Store waste, oily rags, and other flammable material in covered receptacles provided for that purpose. A fire can put you and others out of work. Refuse containers must not be overfilled. Empty these containers frequently. Keep exits clear at all times. Fire doors should never be blocked or made inoperative. Report hand trucks with broken wheels, splintered handles, or other defects to your supervisor so they can be repaired or replaced. When you're pushing a hand truck or cart, Slow down at corners. Be aware of what could happen. Then prevent the happening by taking action before it takes place. Slips and falls are very common types of injuries, but they can be prevented. They can be prevented by watching where you walk, by keeping your shoes free of grease, oil, mud as much as possible, and when you see a hazard, correct it. Don't wait for someone else to take care of it. Safety is everyone's job and responsibility. Adequate illumination of the job is important also. If you can't see what you're doing, the more likely you'll experience an injury. Trial and error doesn't work on the job. It takes an effort on your part to recognize potential hazards, then take the action necessary to prevent the hazard from causing an unplanned event such as an injury. Keeping your tools and machines in good repair and cleanliness is an important job. Watching where you walk is important. Cleaning up spills or picking up lumber to prevent an unplanned event is important. When people fall into ground or floor openings such as shafts, pits, excavations, and temporary floor openings, one or more of the following causes are usually responsible. Number 1, the openings were not guarded or an excavation was not barricaded. Number 2, the openings were not marked with warning devices, lights, or signs. Number 3, tripping or slipping hazards contributed to the fall, such as a person tripped over a material and fell. Number 4, employees worked unsafely at the edge of the opening without proper protection or caution. There are causes for every type of unplanned event. There are also solutions that will prevent these unplanned events. The solution is you. A good safety attitude is the most important ingredient in any safety program. There's no doubt about it. Those employees with good safety attitudes will prevent injuries. Housekeeping and keeping your work area in a neat, clean, and orderly manner is one of the major responsibilities any employee has at work. Do your part and participate in the safety program. It'll mean greater job efficiency, productivity, and it'll also mean an injury-free work environment. Excavations and trench cave-ins account for a growing number of fatalities and serious injuries in construction. Such accidents seldom have a single specific cause. Usually there is a series of separate, yet related causes resulting from such factors. With little or no warning, an unsupported, improperly shored or sloped trench or excavation wall collapse, trapping the workers below in seconds. Active measures on the part of everyone to prevent cave-ins and other job accidents will pay big dividends for everyone. As professionals in the construction business, it's the only way to go. This short program is simply an overview of excavation and trench safety basics. Each company must know and understand current state or federal regulations pertaining to trenches, excavations, and shoring requirements. This program is not intended to explain these regulations, but to make everyone more aware of their responsibilities when working in, near, or around excavations or trenches. Planning for safety begins during the bidding process. The information you need to know to adequately make a bid that may require excavation or trenching includes traffic, nearness of structures and their conditions, types of soil, groundwater, overhead and underground utilities, and the weather. Other conditions can be determined by job site studies, observations, test borings, and by consultations with local officials and utility companies. You must locate any underground installations such as sewer, telephone, water, fuel, cable TV, and electrical lines. If underground utilities are encountered in the digging, they must be properly supported, and the contractor must contact the utility companies involved and inform them of the proposed work. Once you have the preliminaries completed, your safety requirements should be planned to protect the public, the employees, and property. Planning and following through with the plan is the first important step to safety in excavations and trenching operations. Okay, let's take a look at some terminology and on-site safety practices. A trench is referred to as a narrow excavation in which the depth is greater than the width, although the width is not greater than 15 feet. An excavation is any man-made cavity or depression in the Earth's surface. This can include excavations for anything from cellars to highways. Current OSHA regulations require that all excavations over 5 feet deep be sloped, shored, sheeted, braced, or otherwise supported. When soil conditions are unstable, excavations shallower than 5 feet also must be sloped, supported, or shored. You may have heard the term angle of repose. This is a method of ensuring safety in an excavation or trench by sloping the sides of the cut to the angle of repose, which is the angle closest to the perpendicular at which the soil will remain at rest. The angle of repose varies with different kinds of soil and must be determined on each individual project. When an excavation has water conditions, silty material or loose boulders, or when it's being dug in areas where erosion, deep frost, or slide plains are apparent, the angle of repose must be flattened. As you can see in this diagram, each type of soil has varying degrees of angle of repose. Generally, a qualified engineer must determine the proper angle of repose for the specific type of soil condition. A second method of support is shoring sheeting, tightly placed timber shores, bracing, trench jacks, piles, or other materials installed in a manner strong enough to resist the pressures surrounding the excavation. Contractors may also use a trench box, which is a prefabricated movable trench shield composed of steel plates welded to a heavy steel frame. A trench box may be used as long as the protection it provides is equal to or greater than the protection that would be provided by the appropriate shoring system. The soil structure must be carefully identified. Excavations in wet soil, sandy soil, or areas that have been backfilled are relatively unstable and must have strong support. Even hard rock sometimes can be hazardous, as faults in the strata can make it unstable when cut. Changing weather conditions and climate also greatly affect how strong shoring systems must be. Excess water from rain or melting snow loosens the soil, drastically increasing the pressure on the shoring system. A rainstorm can turn a stable trench side that required only light bracing into a mass of loose soil, posing an immediate threat to the employees working within. Shoring frozen ground presents another potential problem. A sudden thaw can undermine an entire section of shoring. Even excessively dry conditions can reduce the cohesiveness of the soil. Large excavations in particular are subject to changing weather conditions because they are generally open for longer periods of time than are trenches. Shoring for these excavations should provide long-range protection for a variety of weather conditions. In some cases, additional precautions are necessary to protect excavation walls, such as covering them with plastic sheeting or spraying the soil bank with a moisture-limiting chemical. Superimposed loads in the vicinity of a trench or excavation increase the pressure on the excavation walls. Heavy equipment and materials such as pipes or timbers should be kept as far back from the excavation as possible. When heavy loads must be located near an excavation, the walls must be braced, sheet piled or shored to safely support the extra weight. In some cases, it may be necessary to lessen the pressure of these loads. Pile drivers or cranes, for example, would be mounted on wooden mats or heavy planking to spread the weight more evenly. Buildings, curbs, trees, utility poles, and other structures adjoining the excavation area also can place more stress on a trench than it can safely accommodate. When this occurs, OSHA requires that employees be protected and that shoring, bracing, or underpinning be provided as necessary to prevent the dislocation of soil beneath the structures in the vicinity. Additionally, spoil, the excavation material, can exert great pressure on the excavation walls. So spoil must be placed 2 feet or more from the edge of the excavation and be barricaded or retained in an effective manner. vibrations or sudden shock from passing vehicles or railways, blasting, equipment such as trucks or pile drivers, and some tools can contribute to cave-ins by loosening the soil. Stronger support in these conditions is vital to the safety of anyone in the trench or excavation. Whatever support system is used, workers should always apply shoring starting from the top of the trench or excavation and working down. In installing the shoring, care must be taken to place the cross beams or trench jacks in true horizontal position and to space them vertically at appropriate intervals. These braces also must be secured to prevent sliding, falling, or kickouts. Installing the shoring should closely follow the excavation work. It's dangerous to allow trenches to remain unshored even if no work is being done in them. Dirt walls will slough off, causing dangerous overhangs. The longer a trench is left unsupported, the greater the chance of a cave-in. In some cases, the contractor will have to guard against an unstable excavation bottom, such as below the water line. Sheeting may have to be driven below the bottom of such an excavation to add to the soil stability. Shoring systems must be inspected daily by a competent person. Inspections also are required after rainstorms or any change in conditions that can increase the possibility of a cave-in or slide. If dangerous ground movements are apparent, all work in the excavation must be stopped until the problem has been corrected. In case of an emergency, workers must be able to leave the trench quickly. When employees are required to be in trenches 5 feet deep or more, adequate means of exit, such as a ladder or step, shall be provided and located so as to require no more than 25 feet lateral travel. Ladders must be in good condition, extend from the floor of the trench to 3 feet above the top of the excavation, and be secured at the top. As soon as the work is completed, the trench should be backfilled as the shoring is dismantled. After the trench has been cleared, workers should remove the shoring from the bottom up, taking care to release jacks or braces slowly. In unstable soil, rope should be used to pull out the jacks or braces from above. A greater awareness of the safety problems to be overcome in excavations, particularly by the individuals who design and install the shoring, will help end cave-in hazards in the construction business. There can be no shortcuts or risk-taking. It's the responsibility of every individual on the job site associated with excavations and trenching operations. To prevent exposure to harmful levels of atmospheric contaminants and to make sure the air you breathe is not harmful, there are a couple of testing and control requirements. When there is an oxygen deficiency, which means atmosphere contains less than 19.5% oxygen, or a hazardous atmosphere exists, or could reasonably be expected to exist, such as in excavations, in landfill areas, or excavations in areas where hazardous substances are stored nearby, the atmospheres in the excavation shall be tested before employees enter excavations greater than 4 feet in depth. Adequate precautions shall be taken to prevent employee exposure to atmospheres containing less than 19.5% oxygen and other hazardous atmospheres. These precautions include providing proper respiratory protection or ventilation as required in OSHA regulations. Adequate precautions shall be taken, such as providing ventilation to prevent employee exposure to an atmosphere containing a concentration of flammable gas in excess of 20% of the lower flammable limit of the gas. When controls are used that are intended to reduce the level of atmospheric contaminants to acceptable levels, testing shall be conducted as often as necessary to ensure that the atmosphere remains safe. There are a number of things to remember in trenching and excavations, but let's just name a couple of important items we haven't fully explained in the program. The angle of the repose should be determined on each project by a competent person. That's the individual capable of identifying existing and predictable hazards in the surroundings or working conditions which are unsanitary, hazardous, or dangerous to employees, and who has authorization to take corrective measures to eliminate them. Daily inspections of excavations, the adjacent areas, and protective systems shall be made by a competent person for evidence of a hazardous situation. An inspection must be conducted prior to the start of work and is needed throughout the shift. Inspection shall also be made after every rainstorm or other hazard-increasing occurrence. It goes without saying, but we'll say it again. All trenches or excavation should be sloped or shored or otherwise protected. No exceptions. Last, but certainly not least, if you think the trench or excavation is unsafe, do not enter it. Safety is important, and in trenching and excavations, safety is absolutely critical. Don't take chances. Follow the rules, and always take time for safety, because you're worth it. Thank you. Hazards in the workplace are a fact of life. No matter what you do, there's the need for personal protective equipment on many of the jobs you perform. Health hazards, eye hazards, noise, and chemicals. Whether or not you use personal protective equipment is really up to you. If you choose not to, your attitude may be the biggest hazard of all. Personal protective equipment is one of the best ways to protect your own health and safety. You've seen it all before. Eye protection that's uncomfortable, equipment that gets in your way, and thousands of other excuses for not wearing protection when it's required. When personal protective equipment is provided by your employer and its use is required, it's your job to wear it. Maybe your equipment isn't comfortable or convenient as you'd like it to be, but you should convince yourself that your health and well-being are worth the effort. Stop for a minute and consider the risks. What if you lost an eye or hand or became exposed to a life-threatening illness? Is it really worth the gamble? Of course not. Let's take a quick look at some basics of personal protective equipment. Earplugs or earmuffs can go a long way to avoid hearing loss. Adjust your muffs so they're comfortable and don't squeeze your ears. Disposable earplugs must be clean and fitted properly. Never insert dirty earplugs or use dirty hands when putting the plugs in your ears. Of course, earplugs connected to portable radios are not considered hearing protection. Safety glasses provide eye protection from flying chips, debris, and other eye hazards. Goggles protect your eyes from chemical splashes, and face shields are a safeguard when worn over other protective eyewear, such as safety glasses. Handy-dandy straps connected to your safety glasses keep them from falling off your nose, or connected around your neck when safety glasses are not necessary. Gloves protect your hands from chemicals, rough or sharp parts, and a wide range of skin protection. Keep in mind that there are literally hundreds of different types of gloves, each designed for a specific purpose, so select the proper glove for the job. Respirators can protect you against a wide variety of dusts, fumes, gases, vapors, and many other health hazards. One of the most misused respirators in the industry is the dust mask. It's designed only for certain types of dust, but many people believe it's good for any type of hazard. A dust mask cannot be used for spray painting or other types of vapors. Each specific hazard must have the proper respirator that provides protection for that hazard. Proper fitting of respiratory equipment and the wearing of equipment as it was intended is equally important. The old standby. Hard hats protect your head from low-hanging or falling objects. Wear hard hats as they were intended to be worn and never make modifications to your hat, such as drilling air holes in the sides. Each hat is engineered for impacts, and if you modify the hat, you could damage the hat to such a degree where the hat will not afford the designed protection. Bump caps are made of lesser quality plastic and are not engineered for falling objects or impacts. Bump caps are used in areas where there are bump hazards and not falling objects. Boots and shoes are good personal protective equipment. Even if your job doesn't require steel-toed safety shoes, leather-topped shoes can provide a degree of protection from chemical splashes, petroleum products, and small cuts, bruises, and abrasions. Your shoes should be in good condition, and the soles of the shoes should be slip-resistant. Keep your footwear in good condition and always clean off your shoes before climbing ladders or getting into vehicles. Grease or slippery shoes can create accidents. Chemical clothing and encapsulating suits are used when there are vapor, gas, and other airborne hazards. When you're engaged in this type of work, more training is necessary to make sure you understand what protection is offered and how to specifically use handle, and store the equipment. When we talk about personal protective equipment, the basic equipment just described comes to mind. But in a work environment, you must consider many other safety devices that could be lumped together with personal protective equipment. Machine guarding isn't just for one individual, but it could be considered personal protective equipment. Electrical safety devices, lock and tag-out procedures, barriers, warning signs, labels, and hundreds of other safety devices should be considered. Safety isn't just one thing. It's a combination of equipment, procedures, and each individual interacting together to make health and safety a reality. Let's say you're spray painting. A proper respirator isn't your only concern. It's how you handle, store, and use the paint. What precautions you take if the paint is toxic or flammable, so you don't expose others or create an explosion. It's cleaning your equipment when you're finished. It's reporting unsafe equipment or hazards to your supervisor. It's your attitude that really makes the difference. If you have a good attitude about safety, follow the rules and take the time to perform your job safely. You can't go wrong. Wearing personal protective equipment when it's required is not only for your protection, it makes good sense to protect your safety and health. Safety glasses can be a pain in the neck because you may not be used to wearing them, or respirators can get uncomfortable from perspiration, or perhaps the straps may not fit just right. Tennis shoes may be more comfortable than leather-top shoes. It may be a hassle not to wear safety glasses under face shields when grinding metal. Gloves may not fit properly, or they're 20 feet away and it's only going to be a short job. You're only going to handle a small amount of chemicals, so you neglect to take proper precautions. These are attitudes, but they really don't add up when it comes to you, your family, and to the company. Safety and health are much too important to neglect. When you're required to wear personal protective equipment, then that's the professional thing to do. You won't regret it.
Effective July 5, 1994, the Occupational Safety and Health Administration requires employers to conduct an assessment of hazards in the workplace that may require the use of personal protective equipment and to certify that such an assessment has been completed. This means the company should identify potential hazards in the workplace and what type of personal protective equipment is to be used for each potential hazard. Documentation that the assessment has been completed is an important part of this requirement. The new rule also requires employers to provide training to employees on identifying when such equipment is necessary, how to use the equipment, and how to properly care for and maintain personal protective equipment. Identifying when equipment is necessary should be accomplished by listing each potential hazard in the workplace, awareness of the hazards, and when personal protective equipment should be used. Generally, safety glasses, gloves, hard hats, safety shoes, and similar equipment is relatively simple to understand. However, specific training may be required of employees who work with pesticides, chemicals, and hazardous materials. Additional training may be required for those employees who may be exposed to respiratory hazards, as identification of these types of hazards are not always apparent. Self-contained breathing apparatus, respirators, and most notably dust masks are items of personal protective equipment that require employee training before using PPE. The stated purpose of the new standard is to improve worker acceptance of wearing personal protective equipment by allowing better and more comfortable designs not presently permitted by older rules. The increased training provides information on selecting the proper equipment for the job. Employees who also have excellent experience and expertise in safety matters should provide their recommendations to supervisors and managers when purchasing new personal protective equipment. After all, safety is a team effort. You can fall from any height and be seriously injured or killed.
In the construction industry, as well as any other industry, when falls from heights happen, they're usually very serious. Some people have actually stated that falls from less than 10 feet cannot hurt you. They are seriously mistaken, because falls from almost any height can cause serious injury or death. That's why it's important to have fall protection and the knowledge to prevent these falls. Basically, fall protection is something that keeps you from falling from a certain height. Whenever you're working 6 or more feet high, OSHA requires fall protection. Right now, let's take a quick look at the different types of fall protection. First, there are guardrails, which consist of a top rail, mid-rail, toe boards, and anchoring posts. Top rails should be between 39 and 45 inches above the walking level, and mid-rails should be located halfway between the top edge of the rail and the walking surface. The guardrail must be strong enough to withstand forces of up to 200 pounds applied within 2 inches of the top edge in any outward or downward position. There are a variety of guardrails such as wood, pipe, steel, cable, and others. Another type of fall protection is safety nets. Safety nets are made from strong synthetic material with holes no more than 6 inches at its greatest dimension. When installing nets, they should be close to people who have the exposure of falling, but never more than 30 feet below the level. With nets, you should check periodically to make sure they remain in good condition and that nothing has fallen onto the net that could create a hazard. Safety nets must be inspected by a qualified person at least weekly for wear, damage, or other deterioration. The third fall protection is a cover. Any opening 2 inches or more in floors or other walking surfaces must be covered. This can be a simple piece of sturdy plywood that will support twice the weight of any worker, equipment, or materials. If you need covers for vehicles, the cover should support twice the axle weight of the vehicle. However, this rule does not apply to cast iron manhole covers or steel grates on streets or roadways. When placing covers over open holes or gaps, write the word hole or cover in large, easy-to-see letters and make sure the cover is securely in place. Next, we have a personal fall arrest system that's specifically designed to protect you in a free fall situation. When you're free falling, you're going at a very rapid speed with weight and distance of the free fall, and when you stop, it's the sudden impact that actually causes injury. The farther you fall without stopping, the greater the impact and potential for injury. Let's take a look at a personal fall arrest system. Generally, it has 5 components: a full body harness, a lanyard, snap hooks, an anchorage point, and the 5th component is knowledge of how the system works and how to take care of the equipment. The full body harness reduces the impact caused by the fall as it spreads pressure evenly over your thighs, chest, shoulders, and pelvis. Body belts, such as the one shown here, are used primarily as a positioning device, which means that if you're working at a height and you're not moving around, the body belt keeps you in this one position. After 1998, body belts can't be used for fall protection. Body belts as a fall arrest system are being phased out because if you fall and are strapped to a lanyard and a body belt, when the lanyard plays out and stops the fall, your body will be severely impacted around your waist, which could lead to an injury from the impact around the middle of your body. The body harness is used for the fall arrest system, and the body belt is basically a positioning device. Let's quickly review how to put on a body harness, keeping in mind there are several types. First, hold the harness off the ground by the D-ring. Check that all buckles are unbuckled and there are no twisted straps. Follow the 2 straps coming out of the D-ring, keeping in mind that one strap has a buckle, the other one doesn't. Slide your left arm into the harness and pull the strap without the buckle over your head. These 2 straps now form an X on your chest, with one strap hanging loose. Take the loose hanging strap and buckle it into the waist strap. Straps on this type of harness always hook up yellow to black, as you see here. Now, hook up your thigh straps, and if you've done everything correctly, the D-ring should be in the middle of your back. The next step would be to attach the shock-absorbing end of the lanyard to the D-ring and the other end of the lanyard to the anchor point. Keep in mind that the body harness will stretch about 1/2 foot during a fall. You need to consider all the stretching factors of the harness, lanyard, and other components so you can judge your stopping distance if you fall. Using a different harness, begin by putting the arms through the shoulder straps and snap the chest strap with plastic snaps. Put the leg straps through the tongue buckles and adjust snug around your legs. Make sure you can touch the D-ring on back of the harness after these steps. Attach the shock-absorbing lanyard to the harness with the locking snap hook. Let's look at it this way. Let's say you're working on a bridge that's 12 feet from the ground. You have a lanyard that's 6 feet long, which means it will allow you to fall about 6 feet before the shock absorber comes into play. As the shock absorber comes up, it allows another 3.5 feet to play out. The body harness will stretch about 1/2 foot. Add in the distance from the D-ring to the worker's feet, which is generally about 4 feet. Adding all this up, you fall 14 feet, hitting the ground at 12 feet. There's more to it than just thinking a 6-foot lanyard will stop you at 6 feet. Many lanyards are only 3 feet because of the stopping distance required. Let's take a look at a drop test. The person demonstrating the drop test has been properly harnessed and has the lanyard attached to an anchoring device. The person drops from a height, and the harness and lanyard stretch and bring the demonstrator to an effective stop without injury. Let's look at it again. You'll notice that a safety net was used in this controlled situation for additional safety. On job sites, appropriate and properly secured safety nets can be used as fall protection. Now let's review the lanyard. The lanyard is attached to the body harness between your shoulder blades and to an anchoring point. There are different kinds of lanyards, such as nylon, polyester, cable, and rope. Shock-absorbing lanyards and rope grabs are designed to absorb most of the force of a fall. Actually, they can be called a deceleration device because they slow, then stop your fall. If the lanyard you're using has been subjected to a fall, tag out the lanyard because it can't be used again. You can tell if it has been used by inspecting the stitching on the tag. If it's been used, the stitching will be torn out. Make sure the lanyard is in good condition, without any defects, tears, or cuts, and the stitching is in place on the tag. Inspect the metal components for signs of corrosion, cracks, sharp edges, or signs of excessive wear. Make sure you know how long your lanyard is when determining how far you will fall before you stop, including the stretch factor of the lanyard and harness. Never, under any circumstances, use fall protection lanyards for anything but fall protection. Lanyards cannot be used to hoist equipment or for any other purpose. There are several types of lanyards, but it's not important to remember the different types. Your company will choose the type of lanyard that best fits your operations. Snap hooks connect the lanyard to your body harness. Connecting is easy by just connecting the snap hooks to the D-ring on your harness. The double locking snap hooks are recommended. However, you may find some non-locking snap hooks which are being phased out by January 1998. One word of caution about snap hooks. Connect them only to the D-rings or anchor point. They cannot be connected directly to the harness webbing or other points, only a D-ring or anchor point. You should always use the proper snap hooks and D-rings of the same size and made by the same manufacturer, and always double check the connection to make sure it's properly locked and in good condition. An anchorage point is the place where your lanyard is attached to a solid, unmovable object which can support up to 5,000 pounds. Keep in mind that you may weigh only 200 pounds, but once you begin to fall, that 200 pounds can turn into a couple thousand pounds of force depending on how far you fall and the speed of the fall. Another factor in fall protection safety is the swing factor. When considering tie-off or anchoring points, if you fall, how far will you swing from side to side? This is a pendulum effect at the end of a fall, which could cause you to hit something if you swing too far. Never anchor the lanyard to a guardrail or similar object. The anchor must be a solid, unmovable object that will support you in case of a fall. When anchored, you should be able to fall no more than 6 feet before you are slowed and stopped. If your lanyard is too short for the job, you must find another good anchorage point and not try to extend the length of the lanyard. As we discussed earlier, the fifth component of a fall protection system is knowledge. Be sure to know how your equipment works, how to properly inspect all components, and if you find something wrong with your equipment, don't use it. Tag it defective and replace it before you continue. Your equipment will work properly as it's designed to do only if it's in good condition and it's used properly. Another important factor in the knowledge component is to never take shortcuts and never fail to use your equipment when you're working at a level 6 feet or higher that requires fall protection. Certainly, fall protection systems can be awkward to use, and in some cases, your company may have to resort to other methods of fall protection. A warning line system for a controlled access zone may be put into effect. This controlled access zone could mean an area where certain work, such as overhand bricklaying, where fall protection may not be feasible. A restricted entrance to this area is implemented, and there is a warning line system that uses rope, chains, or wires to keep anyone out of areas where they could fall. Of course, these areas must be properly designated with signs and lines marked with high visibility material that are easy to see. When control lines are used, they must be erected not less than 6 feet but no more than 25 feet from the unprotected or leading edge. There are exceptions to this rule when erecting precast concrete members. If you're using this system, make sure you follow the rules and warnings. Next, a safety monitoring system and competent person is another way to prevent falls. Let's examine the definition of a competent person. A competent person is one who is capable of identifying existing and predictable workplace hazards in the surrounding or working conditions which are unsanitary, hazardous, or dangerous to employees, and who has the authority to take prompt corrective measures to eliminate them. You must have a competent person designated as a safety monitor, and that person's job is to actively patrol the work area and warn others of any possible danger. This is a full-time job, and the monitor must be able to recognize fall hazards and cannot perform other work duties. The safety monitor is a full-time job while employees are exposed. Another option is a fall protection plan. This should be used only when all else fails, in situations where other options may not work. Your company will advise you when this option is used. What type of training and documentation is required? The employer is required to provide a training program for each employee who might be exposed to fall hazards. The program allows each employee to recognize the hazards of falling and shall train each employee in the procedures to be followed in order to minimize the hazard. A competent person qualified in fall protection shall explain the nature of all hazards in the work area, the correct procedures for erecting, maintaining, disassembling, and inspecting the fall protection systems to be used, and the use and operation of guardrail systems, personal fall arrest systems, safety net systems, warning line systems, safety monitoring systems, controlled access zones, and other protection to be used. Employees must be trained in their specific roles when using the safety monitoring system and the limitations on the use of mechanical equipment during the performance of roofing work on low-sloped roofs. Employees must be trained in the correct procedures for the handling and storage of equipment and materials, and the erection of overhead protection, and the role of employees in fall protection plans, and the OSHA standards pertaining to fall protection. A written certification record must be completed with the name or other identity of the employee trained, the date of the training, and the signature of the person who conducted the training or the signature of the employer. Retraining is required when the employer has reason to believe that any affected employee who has already been trained does not have the understanding and skill required. The employer must retrain that employee. Retraining is also required when changes in the workplace render the previous training obsolete or changes in the types of fall protection systems or equipment to be used render previous training obsolete. In other words, employees must be kept aware of proper fall protection, OSHA standards, fall protection equipment, and everything necessary to prevent falls. It's an important responsibility, and this training program has provided the majority of information you need to help prevent falls. However, more information will be provided by your trainer, supervisor, or company to make sure all proper training has been conducted. This is only an awareness of fall protection. It's up to you to make sure you understand fall protection, proper equipment, signs, signals, rules, and standards to prevent falls. If you have any questions, be sure to ask your trainer or supervisor because your safety is much too important to leave any questions unanswered. As a review, let's take a look at when you need fall protection. Fall protection is required on unprotected or leading edges where the height is 6 or more feet above the lower surface. You can choose to use a guardrail system, fall arrest systems, safety nets, safety monitoring systems, or controlled access zones. Where there are holes where people can fall through, guardrails and covers can be used. On ramps, walkways, and runways, guardrail fall protection should be used. When working on reinforcing steel and other vertical surfaces, including formwork, personal fall arrest systems, safety nets, or position devices such as a body belt should be used. For hand bricklaying, guardrails, safety nets, or personal fall arrest systems should be used. On low-sloped or steep roofs, controlled access zones may offer proper fall protection. Precast concrete erections use guardrails, safety nets, personal fall arrest systems, or a fall protection plan. For excavation fall protection, you can use barricades, fences, or guardrails. Wall openings require guardrails, safety nets, or personal fall arrest systems. Fall protection means many things. How about people working overhead where tools or materials can fall to people working below? Generally, that's why toe boards and hard hats are required on construction sites. The same applies for powered lifts, toe boards, and conscientious workers making an effort not to let anything fall below. What happens if someone does fall and injures themselves? Do you have a plan and understand your company's rescue plan? If a fall occurs, a fall arrest system will work, but how do you retrieve the person? You may need a crane or hoist. If the injured person is near a bridge, you may need traffic control and signals, as well as some method of attaching a rescue rope to the individual. Quickly, let's retrieve a person who has fallen. First, determine the extent of any injuries and, if required, get medical help before moving the victim. If there are no serious injuries requiring medical attention, let's use a crane and recovery pole to rescue the worker. To use the recovery pole, attach one end of an anchor sling to a carabiner and attach that carabiner to the hoist line hook. Place a carabiner through the other end. Lower the hoist line with the recovery pole down to the fallen worker and hook the carabiner through the D-ring of the body harness. It's easier to attach the line from an angle rather than from straight above. Twist the pole and pull to lock the carabiner onto the D-ring. After making sure the fallen worker is secure on the hoist, cut or disconnect the original lanyard. Now raise the person to safety. Understanding the basics of a proper rescue and rescue equipment can reduce injuries. It's an important part of safety.
Thank you.
As we look back on injury experiences, one frightening thought comes clearly in focus. Hand and power tools cause thousands of injuries every year. Everyone uses hand and power tools, at work and at home, but even the simple screwdriver causes over 100 deaths each year. It's difficult to get excited about hand and power tools, but the injury rate tells us safety is extremely important when using this equipment. This program can't possibly cover all hand and power tools and all the safety rules associated with using these items, but the point we want to stress right up front is safety must be exercised every time anyone uses hand and power tools. Safety awareness is of vital importance. So let's begin the program with some basics. A good safety attitude is the first step in injury prevention. If you're aware of the potential hazards, then do something about these hazards to protect yourself and others. Then you have a good safety attitude. Safety behavior is a term used quite frequently, but all it means is a person exercises good judgment, follows safety rules, and doesn't take shortcuts to get the job done. Safety behavior reflects your safety attitude, and it certainly doesn't take any more time, effort, or anything else on your part to be a truly safe employee. It does require you to use good judgment and follow the safety rules established by your organization. Okay, the first rule for hand and power tool safety is to use equipment that is in good, safe, serviceable condition. Regardless of who provides the tools and equipment, either you or your employer, all tools and equipment must be in good, serviceable condition. Defective equipment must be taken out of service and not used until it is repaired or replaced. Okay, let's take a few seconds to talk about knuckle skinners, also known as wrenches. Most wrench accidents are caused by the wrench slipping off the bolt or nut you're trying to turn. Knuckles and fingers bang into surfaces, causing minor injuries. When you're turning something with a wrench, be prepared for the wrench to slip so the injury can be prevented. If you're prepared, you'll prevent the injury. When using long-handled wrenches, position your feet and body in such a manner so that if the wrench slips, you won't take a fall. Another safety tip is to make sure the wrench opening fits snugly on the nut or bolt. A loose fit damages the tool, and it certainly increases the injury potential. Never try to use metric wrenches on inch fasteners or vice versa. Use the proper tool for the job. One of the worst safety violations is to use a cheater bar. A cheater bar is something like a pipe placed on the wrench or tool to give you more leverage. Your wrench or tool is designed only for hand pressure, and when you add a cheater bar, you're exceeding the safety design of the tool. Just say no to cheater bars. Certainly, there are times when you need to loosen a frozen nut or bolt, and hand pressure won't do it. That's when you need to use a heavy-duty striking tool and some penetrating oil. The striking tool is designed to be hit with a hammer and will do the job, so you don't have to use a cheater bar or other hazardous operation to free that frozen bolt or nut. There are basically three types of socket wrenches and sockets: hand sockets, power sockets, and impact sockets. Never mix the different types. In other words, don't use a hand socket on an impact wrench. Each type is designed for a specific wrench, and when you use the wrong socket, you can easily damage the wrench or socket. If you're using an impact wrench, use only impact sockets designed for the job. Adjustable wrenches are very versatile, and they're used for a variety of jobs. One of the major causes of injuries with adjustable wrenches is using damaged wrenches. When the adjustable threads become worn, or the surface on the inside of the jaw becomes rounded from use, the tool is unsafe to use. Replace this damaged tool with one in serviceable condition. It may seem like a simple solution, and it is, but adjustable wrenches that are worn out should be replaced. The same basic rule applies to bench vices. When the jaws of the vise become worn, it's time to replace the jaws. You don't have to replace the whole vise, just the worn jaws. Another tip for bench vices is to make sure they are securely fastened to the work table or bench. Power tools and equipment require special attention because when an injury does occur, it's usually very serious. Not much room for error on powered equipment. Before you use any power tool, inspect it to make sure it's in good condition and has no defects or safety hazards. If your power equipment uses cutting blades, bits, or other such attachments, make sure they are sharp and in good condition. Dull blades and bits can cause damage to the material you're cutting and can also contribute to personal injury. Be sure all your equipment is in proper working order. Electrical tools have at least one safety device to protect the user from electrical shock. This safety device is called grounding, and in some cases, double insulation. Let's review grounding because this is the most common protection on electrical tools and appliances. Grounding means there is a third wire in the tool running through the third prong in the plug. There is a grounding wire or connection from the electrical power source or receptacle that goes to earth or ground. In the event of an electrical short or other malfunction of the tool, electricity will flow through this ground to earth and not through your body. If the ground prong is broken off, or the ground wire is broken, or there is a gap in the electrical ground, the electricity will have nowhere to go except through the person holding the tool. This tells you that it's very important to inspect your electrical equipment for defects before you use the equipment. Some tools afford you shock protection by double insulating the inside of the tool. In the event of a short or other malfunction, the operator is protected by this double insulation. You may notice some electrical tools that only have two prongs on the electrical plug. The first thing you should do is check the manufacturer's data plate for the words double insulated. If you see an electrical tool with only two prongs and the tool does not state it is double insulated, then do not use this particular tool until it's replaced or repaired for the proper ground. Regardless of the type of shock protection on your electrical tool, it won't help if you're using the equipment near water, liquids, or other unsafe conditions. Sweaty palms or perspiration when using electrical tools is also unsafe, as a wet or moist environment is extremely hazardous around electricity. Another good tip is never carry any equipment by the electrical cord. Yanking cords out of the wall receptacle by the cord is also unsafe. Remove the plug from the wall receptacle by holding the plug, not the cord. When using any type of electrical equipment, always inspect the plugs, cords, cables, and attaching hardware for frays, cracks, cuts, or damage. Electricity is nothing to fool with, so don't take chances with your equipment. If it's not safe to use, don't use it. You've all seen or probably used octopus receptacles and plugs to increase the electrical outlets. When you do this, you're exceeding the design of the wall receptacle, and if you use too much current or amps, you can trip circuit breakers and, even worse, overload the circuit and quite possibly cause a fire. Don't use octopus plugs. Another safety factor around electricity is using three-prong adapters, such as the one shown here. It has three prongs for you to insert your grounded plug, but it only has two prongs for the receptacle. The idea is to use this grounding wire and connect it to the wall receptacle, which is supposedly designed to ground the system. These types of plugs are unsafe and should never be used in any industrial environment. In fact, they should never be used in your home either. Okay, let's quickly review some more basic safety tips. The first tip is relating to power drills. All drill bits must be sharp in order to drill safely. Dull bits can damage the material or can break and cause a serious injury. Be sure drill bits are sharp and in good condition. When you're drilling, don't use excessive force. If you need a larger drill or some other type of equipment to do the job, that's okay. But don't try to bully a drill bit into material by using excessive force. When you're tightening a drill bit into the chuck, be sure it's properly tightened, and never tighten the drill bit with anything other than the proper chuck. If you use screwdrivers or other makeshift chucks, you're asking for trouble. When using portable hand saws, always make sure the guard is in place and working properly. Never remove the guard or tie it back. Mechanical guards are designed for your protection, and it's really unsafe to render any guard inoperable. There is always a safe way to use your equipment. Taking chances, such as using your leg as a workbench, is an accident waiting to happen. It doesn't make sense. Everyone wants to complete their job as quickly as possible. But think about the time off from work that results from an injury. The 10 seconds you save becomes 10 or more hours of lost time. When you're working with hand and power tools, your safety attitude and common sense are the two most important parts of your job. Your organization can have the most effective safety rules and the best equipment, but if you neglect the attitude part, you're heading for trouble. Recognize the potential hazards of the job, such as sharp edges, falling objects, extreme heat or cold, chemicals, flammables, and electricity. Think through each task before you do it, and know what you're asking of your hands and body. Follow the safety rules, even if you've gotten away with shortcuts before. In the event of an injury, even a minor injury, report it to your supervisor when it occurs, so medical attention can be provided if it's needed. Use personal protective equipment when it's provided and necessary, and think about safety on every job you perform. Hand and power tools are very safe to use if you follow the rules. Follow your organization's safety policies and procedures, and you'll find that your job is easier, quicker, and you'll be a safer employee. It's that simple.
Almost every industry and many homes use ladders. Each year, thousands of people are injured by falling off ladders. So right now, let's begin a review of the safe way to use ladders. It's more than just climbing on a ladder and exercising caution. It begins when you first select your ladder. In offices, small step stools are used to reach high places, but these are not considered ladders. They are step stools, and they can be dangerous also. On step stools, be sure they are in good condition and do not have slippery surfaces. Never stand on a chair or other makeshift step stool. Always use the proper device for the job. The next category, and one that causes the most injuries, are step ladders. One simple mistake can cause a serious injury. The very first safety rule when using step ladders is to inspect the ladder. Check the steps to make sure they are not slippery. Quite often, grease, oil, solvents, and other materials can be left on the rungs or sides of the ladder and can cause you to slip and fall. Inspect the ladder. All wood parts should be free from sharp edges and splinters. Wooden parts must be physically sound and free from compression failures, decay, or other irregularities. Low-density wood should not be used on wooden step ladders. The metal spreader or locking device of sufficient size and strength to securely hold the front and back section in open positions shall be a component of each step ladder. The spreader shall have all sharp points covered or removed to protect the user. Basically what we're saying is the ladder must be in good condition and maintained in that condition, or it cannot be used. Naturally, good footing is important when placing ladders. Never place ladders on boxes, barrels, or other unstable bases to obtain additional height. Make sure the ladder is tall enough to do the job, because you can't step on the top two steps of any step ladder. Basically, step ladders are designed to be used at the center of gravity, and if you stand on the top two steps of any step ladder, your weight is past the center of gravity and can easily tip over the step ladder. Another good rule to remember is the belt buckle rule, and this also reflects upon the ladder's center of gravity. You should keep the center of your body within the inside rails of the ladder. If you lean out past the side rails, the center of gravity of your body and the step ladder can cause the ladder to fall to one side. That's why it's called the belt buckle rule. If you must use materials or tools, hoist them up with a rope or other device. You need both hands when climbing up or down a ladder. Of course, when using step ladders, don't place them near doors, because an opening door could create an accident. While we're on the subject of step ladders, let's talk about metal step ladders. All the same rules apply to metal ladders as with wooden ladders. However, let's add one more rule. Never use a metal or aluminum ladder when working with electricity. That means even when you're changing a light bulb. The metal or aluminum ladder could easily contact an energized electrical wire and serve as an excellent conductor of electricity, and you can imagine the result. Don't use metal or aluminum ladders near electricity. When using straight ladders, there are several important safety tips to consider. All ladders must be inspected before use. They must be free of dirt, grease, or slippery materials. When placing a straight ladder on a working surface, use the 4-to-1 rule. For every 4 feet of length of the ladder, it should be placed 1 foot from the vertical surface on which you rest the ladder. What this means is that when setting up a straight ladder at the proper angle, you place the base a distance from the vertical wall equal to 1/4 the working length of the ladder. As you can see, a 12-foot ladder would be placed 3 feet from the vertical wall. This provides rigid support and keeps the ladder within its design center of gravity. Never use any ladder in a horizontal position as runway or as scaffolds. Okay, the next rule on straight ladders is when you're gaining access to a roof or landing. Make sure the ladder extends past any landing or roof at least 3 feet. This provides you with hand support when getting on or off the roof. It is highly recommended that ladders be tied off in some manner to prevent it from slipping from side to side. There are many other types of ladders and climbing devices, such as rolling scaffolds, stationary scaffolds, but the greatest number of injuries come from everyday step ladders and straight ladders used in industry and in the home. In many retail organizations, they use platform-type ladders with rolling wheels. When a person's weight is applied to the platform, the ladder pushes down and is stabilized by metal feet. Inspecting the wheels and the device that stabilizes the ladder would be an important consideration in the safety of platform ladders. Making sure the ladder's steps were completely clean and free of grease or other slippery surfaces is another important part of ladder safety for platform ladders. Using the handrails when walking up or down the ladder. On platform ladders, some organizations allow the carrying of material or merchandise on platform ladders, but the sensible thing to do is not carry anything that is awkward or too heavy. Overextending the ladder is going past the center of gravity. Standing on the rails to get extra height is unsafe. Regardless of the type of ladder you use, there is a safe method of using the ladder. Be sure you know and understand the rules. Then use your good judgment in following these rules. There's nothing secret about safety, nothing exotic or mysterious. Just plain common sense. Safety rules and procedures are nothing more than experience. When you use a step stool, step ladder, straight ladder, platform ladder, scaffold, or any type of equipment, think about the potential hazard. Then use your good judgment to reduce your risk. Take the time for safety because you're worth it. There isn't any job you can't perform safely if you just follow the rules. If it can't be done safely, you shouldn't do it.